Imagine you could instantly teleport to any point in the solar system. Forget Mars or Jupiter's moons. Our destination is the very center of the system, the sun's hypothetical surface. This journey would last less than a second because you simply wouldn't survive any longer. Your existence there would be 300,000 times shorter than the blink of a human eye. You wouldn't just be burned, you would simultaneously be vaporized by plasma, torn apart by gravity, and pierced by lethal radiation. This is the most brutal and rapid annihilation imaginable. But how exactly does it happen? Our star, which gives us life and light, is actually the deadliest place in our system. It's like the ancient gods, such as the Egyptian Ra, who was both the creator of the world and a scorching deity. To understand this paradox, we must break down this nightmarish moment into three fundamental components: unimaginable temperature, crushing gravity, and an invisible stream of deadly radiation. Which of these forces would strike first? Before we continue, an important clarification: the sun has no solid surface to stand on. What we see from Earth is the photosphere, a boiling layer of gas several hundred kilometers thick. Paradoxically, the density of this surface is hundreds of times lower than the air we breathe. It's almost a vacuum, but a vacuum heated to thousands of degrees. This hypothetical boundary is what we will consider our arrival point. It's not solid ground beneath your feet, but the edge of a raging ocean of plasma, and we are about to dive straight into it. The first thing you'd encounter is a temperature of around 5,500 degrees Celsius, 992 Ders. But this figure is deceptive. This isn't the heat from a bonfire or a scorching oven. At such a temperature, matter ceases to be a gas and transitions into a different state, plasma. This term was introduced in 1928 by chemist Irving Langmuir, who compared this ionized gas to blood plasma, which transports cells throughout the body. Solar plasma is also a transporter, but not of life, rather of pure energy. It's a subatomic soup where electrons are stripped from their atomic nuclei. You wouldn't be entering a fire, but an active chemical environment that disassembles everything it touches into its constituent particles. This plasma isn't static. The sun's surface is the top of gigantic boiling cells, each the size of Texas. This pattern, which astronomers call granulation, resembles grains of rice scattered across a plate. Hot plasma from the interior rises to the surface, releases heat, cools, and then sinks back down. You would arrive precisely at the center of this turbulent cauldron. Heat here is transferred not just by radiation, but by direct contact with matter that instantly imparts energy to your body, capable of vaporizing any known material, including the most refractory metals like tungsten. Your body is 60% water. In the conditions of the photosphere, this water wouldn't just boil, it would undergo an instantaneous phase transition, a process that would occur faster than a camera flash. Water molecules and organic compounds would break down into their constituent atoms in a fraction of a microsecond. Burning or melting wouldn't even have time to begin. It's more akin to erasure. Your body would simply cease to exist as a complex structure and become part of the solar plasma. Where does this endless energy come from? Deep within the sun's core, at pressures 250 billion times greater than Earth's, thermonuclear fusion is taking place. Every second, 600 million tons of hydrogen are converted into helium. In this process, according to Einstein's famous formula, about 4 million tons of matter are completely transformed into pure energy. This is equivalent to the explosion of 91 billion megaton hydrogen bombs every second. The energy from this reaction, in the form of photons, travels to the surface for hundreds of thousands of years. The heat that would destroy you is an echo of processes that began during Earth's ice age. So the first killer is absolute heat, which doesn't burn but disintegrates. It acts instantaneously, leaving no trace. If this were the only threat, your story would end here, in a cloud of superheated atoms. But even if you were made of material capable of withstanding this temperature, a second, equally brutal enemy would already be waiting for you. This enemy is gravity. The sun contains 99.86% of all the mass in the solar system. Because of this, the force of gravity on its hypothetical surface is nearly 28 times that of Earth. A person weighing 80 kilograms on 176 lums would weigh over 2,200 kilograms, 48 lums here. That's the mass of a large SUV suddenly becoming your own weight. For comparison, the most resilient human in history, U.S. Air Force Colonel John Stapp, withstood a momentary acceleration 46 times greater than Earth's gravity, but that was an acceleration acceleration lasting an instant. On the sun, you would constantly experience a load 28 times the norm, and this is not acceleration, but static, crushing weight. What does this mean in practice? The instant you appeared, your skeleton, designed to withstand only minor stresses, would be pulverized into dust. But that's just the beginning. Your internal organs would be crushed by their own greatly increased mass. Your lungs would collapse, and your heart would be powerless. It simply wouldn't be able to pump blood, which would become similar in density and weight to liquid mercury. No heart muscle is capable of moving such a heavy mass. This would be an instantaneous and complete failure of all bodily systems. But the sun's gravity kills in more sophisticated ways. Due to the star's colossal size, there's a noticeable difference in the gravitational pull between your head and your feet. The force acting on parts of your body closer to the sun's center would be significantly greater than on those farther away. This effect, known as tidal forces, would literally begin to stretch you like a rubber band. Astrophysicists call this gruesome process spaghettification, and while it's more commonly associated with black holes, it would be no less effective on the sun. Even if you were in the most robust spacecraft, this gravity would be a trap. To escape the photosphere, you would need a speed of 617 kilometers per second, 383 miles per second. To break free from Earth, you only need 11. This is almost 3 times faster than the record speed of the Parker Solar Probe. No man-made engine can generate such thrust. The sun is a gravitational well from which it is almost impossible to escape. Thus, even if you were invulnerable to heat, you would simultaneously be crushed and torn apart. Your body would cease to be a single entity, becoming biomass flattened onto the boiling surface. But the story doesn't end there, because there is a third force, an invisible killer, that would begin to act even before you could feel the heat or the weight. This is an attack at the level of atoms themselves. The sun constantly emits a stream of charged particles, protons and electrons, known as the solar wind. On Earth, we are protected from it by a powerful magnetic field, but on the sun's surface, you would be at the epicenter of this storm. The stream rushes at speeds of 400 to 800 kilometers per second, 250 to 500 miles per second. It would pierce your body like microscopic bullets, ionizing atoms and destroying complex molecules like DNA. This is sterilization at a cellular level, but that's just background noise. On the sun, unpredictable and violent events occur: solar flares and coronal mass ejections. These are giant eruptions of energy and matter. A single powerful flare releases energy equivalent to millions of hydrogen bombs. In 1859, during the Carrington event, a medium-strength flare caused telegraph systems on Earth to fail and auroras to be visible in Cuba. Being near such an event, you would receive a radiation dose billions of times greater than lethal in a fraction of a second. The sun's radiation is not only particles, it's the entire electromagnetic spectrum, including high-energy X-ray and gamma radiation. Imagine the X-ray dose you receive at the dentist. Now multiply it by trillions. These photons possess such energy that they penetrate matter, knocking out electrons and breaking chemical bonds. This is radiation from which no spacesuit can save you. It destroys you from within at the most fundamental subatomic level. To understand the scale of this threat, one only needs to look at Earth. Our magnetic field, generated by a liquid core, deflects most of the solar wind. This protective region, the magnetosphere, extends tens of thousands of kilometers into space, acting like an invisible force shield. The small amount that breaks through is what we see as beautiful auroras. This beautiful phenomenon is a vivid demonstration of the deadly battle continuously occurring in the upper layers of our atmosphere. Thus, the third force ensures that even if you were like a disembodied spirit invulnerable to heat and gravity, your informational structure would be erased by a torrent of energy. It's like directing a powerful electromagnetic pulse at the hard drive of your brain, instantly and irreversibly formatting all data. This is the most pervasive and inescapable of the 3 killers. The key point of our thought experiment is that these 3 forces don't wait their turn. They don't act sequentially. They descend upon you simultaneously in the same fraction of a second. It's not a duel, but a coordinated attack from 3 directions. Radiation is an airstrike, heat is an artillery barrage, and gravity is a crushing assault. It's a perfect storm where each destructive factor amplifies the others. Plasma destroys any physical protection from radiation, and gravity leaves no chance to evade their combined effect. Let's imagine this process in extreme slow motion. In the first nanosecond, a stream of gamma rays and protons transforms your DNA into a chaotic jumble of atoms. This happens in the time it takes light to travel just 30 centimeters. 1 foot. In the next nanosecond, gravity pulverizes your skeleton, and almost at the same instant, plasma absorbs these fragments, making them part of the star itself. This is why you wouldn't survive on the sun for even a second, because your complete annihilation would take only fractions of a microsecond. This isn't death in the sense we usually understand it. It's the ultimate form of recycling, an instant return to the primordial stellar cauldron. It's complete and absolute erasure, a reversion to the state of elementary particles from which all matter in our system once originated. But here's the main paradox. This machine of destruction, the most hostile place we can imagine, is simultaneously the sole reason for our existence. All the deadly forces we've examined are the flip side of the processes that give life. The sun is our cosmic Dr. Jekyll and Mr. Hyde. It's a perfect example of nature's duality, creation and destruction in a single object. The very heat that would vaporize us on the surface, after traveling 150 million kilometers and into 93 million miles, weakens to an ideal level. It warms our planet and keeps water in a liquid state, which is the main condition for life as we know it. The very photons that bring death up close on Earth trigger photosynthesis, the basis of all food chains. Every ray of light we see has traveled 8 minutes and 20 seconds to reach us. In that time, a lethal dose of radiation transforms into life-giving energy. The sun is a giant battery that powers our civilization, and the very gravity that would tear us apart at a distance works as a great architect. It holds Earth in a stable, nearly circular orbit within the so-called Goldilocks zone. If our orbit were just a few percent closer to the sun, the oceans would boil away. A few percent farther and they would freeze. The sun's gravity is not just an anchor, it's a super precise regulator. It prevents our planet from drifting into cold space or falling into the star's scorching embrace. It's the guarantor of our stable climate for billions of years. And finally, the deepest aspect, all elements heavier than hydrogen and helium, which make up our planet and our bodies. The carbon in our cells, the oxygen we breathe, the iron in our blood, were created in the process of thermonuclear fusion. They were born in the hearts of stars that lived and died long before our sun came into being. As astronomer Carl Sagan loved to say, we are made of star stuff. We are literally composed of stardust. Thus, the difference between the sun as a killer and the sun as a creator is nothing other than distance. Distance is the best and simplest protective screen in the universe. Our existence is the result of a perfect balance, a fragile equilibrium that allows us to receive all the benefits of our star while avoiding its deadly fury. So where has this thought experiment led us? It has shown that survival on the sun is impossible for 3 simultaneous and interconnected reasons. These are the 3 horsemen of the solar apocalypse: heat, gravity, and radiation. The first force doesn't burn but instantly disintegrates matter. The second simultaneously crushes and tears apart any structure. The third destroys life at a subatomic level, but the most important discovery of our journey lies elsewhere. We have seen that the sun is a perfect example of the universe's duality. Its proximity means guaranteed death, but its distant, perfectly calibrated presence is a necessary condition for the emergence and sustenance of life. It's reminiscent of the old saying that the only difference between poison and medicine is the dose. In our case, that dose is a distance of 150 million kilometers, 93 million miles. At this distance, deadly energy becomes life-giving, and the gravitational tyrant transforms into a caring orbital guardian. Our survival is not a given, but the result of an incredibly fragile balance. And by studying why we would inevitably perish on the sun, we actually learn why we are still alive on Earth. Our planet is not just our home, it is our cosmic spaceship and our shield, flying in a perfect orbit around a star that is both our creator and our potential destroyer. It is that pale blue dot Carl Sagan spoke of, the only place we know where the deadly fire of a star transforms into warm light. And realizing this fact is perhaps the best reason to appreciate the unique and safe corner of the cosmos that we occupy.